The emphasis of today's lesson, section 1.3, is in solving equations, and that's really going to take two different forms. In the beginning of the lesson, we're going to be doing what is should be a pretty common procedure. We're going to find the actual number that would plug in for a variable to make the equation true, otherwise known as the solution. And then the second half of the lesson, we're going to take a look at solving equations that are given to us in terms of one variable. They're solved for one variable, but we're going to change that equation so that it's solved for a different variable. So our answer isn't going to be the variable equals a number, but it's just the variable equals the rest of the equation. And we'll take a look at what that looks like in the second half of the lesson. So some pretty easy examples here. What I'm about to do is what you're going to do on problems 2 through 16 even. And you learned probably in Algebra 1 that if you're going to solve for z, which is what we're doing in this case, we need to make sure, first of all, that the z is on one side of the equation only. And we use sometimes the expression kill the little one. And if we're looking at the z terms, the smaller of the two z terms is 5z. So you can think of the word cancel if you'd prefer rather than kill. But I'm going to focus on canceling or killing the term 5z. Since it's positive, or you can think of plus, then I'm going to do the opposite operation, which is subtract. So this is an example of what is known as inverse operations. We take a positive, or think of that as being plus 5z, and we subtract. We just do the opposite of adding. So 8z minus 5z is 3z. Bring down the plus 12. On the right side, those 5z's will make 0 when combined, and we're left with minus 21. Okay, well, you probably know the drill, but I'm trying to emphasize in class that solving an equation for a particular variable involves a process that we call inverse operations. And when there are more than one operation, when there's more than one operation in or on one side of an equation, then when we're solving, we do the inverse operations in reverse PEMDAS order. Okay, so for example, in this case, we're down to, there are two operations being performed on z. One of them is addition, and the other one is multiplication. Well, according to our process, I'm going to undo these using inverse operations in reverse PEMDAS order. So that means I'm going to undo addition first, and then I would undo multiplication second. Okay, and the way I undo addition is with subtraction. So the opposite of adding 12 is subtracting 12. And that leaves me with 3z on the left side is equal to negative 33 on the right side. Okay, so addition is taken care of, and now all that's left is undoing multiplication. And we've been discussing in class, there are really two ways of undoing multiplication. You could divide by 3 in this case, and we would be left with z equals negative 11. And it's also appropriate because not only could you divide, but you could multiply by the inverse of 3 in this case, or the reciprocal of 3, which is 1/3. And I'm not saying you have to do both of these, but I just wanted you to be aware, if you're not already, that really undoing multiplication can be done in either one of these. Division by the factor, or multiplication by the inverse of the factor or the coefficient. Okay, so we get our answer here as z equals negative 11, and I'm going to leave it up to you as to whether or not you check to make sure this is right. You don't have to show me your check, but it's a good idea to give yourself confidence, even if it's a mental check, to make sure that when z becomes 11, or negative 11 in both cases, when we replace z with negative 11, the left side of the equation should equal the right side. All right, here's another one. Same type of problem. We have t terms on both sides of the equation. So I'm going to focus on the smaller t term, and I'm going to do the inverse of what it says. This is subtracting 4t, and the inverse, or the opposite of subtracting 4t, is adding 4t. So remember, whatever you do to one side of an equation, you must also do on the other side. So I lined up the like terms. 2t plus 4t is 6t. Bring down the minus 3. On the right side, these t terms will cancel, becoming 0, leaving 9. And then once again, I'm going to do inverse operations in reverse PEMDAS order. So in reverse PEMDAS order, I would undo subtraction before I would undo multiplication. And the way I undo subtracting 3 is by adding 3. And we'll do that on both sides. 6t is equal to 12. And then once again, I could divide by 6 on both sides, or I could multiply by 1/6 on both sides. Same result. I'll just show multiplication by the inverse of 6. So t is equal to 2. All right, let's take a look at another example. This time, before we begin solving for y, it's going to become necessary to remove parentheses, and we're going to need to do that by applying the distributive property, which you probably remember. In this case, we're going to be distributing 2, since 2 is being multiplied times this quantity y minus 3, then 2 needs to be multiplied by both of the terms inside the parentheses. So 2 times y would give us 2y, and then 2 times negative 3 is negative 6. Bring down the plus 6, and that equals 70. Always take advantage of opportunities to combine like terms. I used to say CLT, combine like terms. And we have like terms here because these are constants that could be put together, and negative 6 plus 6, of course, is 0. So that gives us 2y equals 70. And once again, the way we undo multiplication is either with division, shown here, or I could have chosen to multiply by the inverse of 2, which is 1/2. All right. Here's another example of applying the distributive property. We need to get rid of these parentheses first. So let's multiply 4 times both of the terms inside the parentheses. 4 times m is 4m, plus 4 times 9, which is 36. And we'll do the same type of thing on the other side. Negative 3 times m is negative 3m. And negative 3 times negative 4, negative times negative is a positive 12. Okay, it's necessary to put the m variable on one side of the equation only. So thinking about our little expression, kill the little one, the smallest of the m terms is this negative 3m. The opposite of subtracting 3m is adding 3m. So I'm going to do that on both sides. Lining up the like terms. 4 plus 3m is 7m. Bring down plus 36. This would create 0, and then I'll bring down the 12. So once again, I'm doing inverse operations in reverse PEMDAS order. So I would undo addition first with subtraction, giving me 7m is negative 24. And then I'm going to undo multiplication with division, giving me m is negative 24 sevenths. And it's fine in this class, and this is always true, for you to leave fractions in improper form. You do not need to change these to mixed. You do, when this situation arises, you do want to reduce or simplify, but you don't have to change these into mixed numbers or decimals. You can just leave them as improper fractions. Okay, now the problem's changed a little bit. Now we're into that second objective that we talked about at the beginning of the lesson, and you're going to be doing the same type of thing on these homework problems. And that is, we're given an equation solved in terms of one variable, but we're going to change the equation so that it's solved for a different variable. Okay, so really that same principle is true. It's all about inverse operations. And if there's more than one operation on a side, then we follow PEMDAS in reverse. Well, in this particular case, there isn't more than one operation. It's really the same operation, just being applied with two different numbers. 2 is being multiplied times r, which is what we're asked to solve for, and pi is also being multiplied times r. Well, since both of them are being multiplied, we can just undo both of them at the same time. Remember, the way we undo multiplication is with division. And since I'm going to divide by the product of 2t on the right side, then I must also divide by 2pi on the left. So whatever you do to one side, remember you must do to the other. And so on the left side, we end up with c divided by 2pi. And on the right side, we will end up with r, which is what we were asked to solve for. So that would be our final answer. The formula was given to us in terms of the circumference, and now we've changed it so that it's given in terms of the radius. Okay. Let's try another one. Here's an area formula. And once again, we're supposed to solve for h in this case. And so I would just encourage you to take a look and see what operations are being performed on h. And it looks like we have multiplication by 1/2. We also have multiplication by this quantity, b1 plus b2. So the way we'll just start with the 1/2. How do you undo multiplying by 1/2? Well, we've looked at that property several times already, the inverse property of multiplication. I undo multiplying by 1/2 by multiplying by its reciprocal, which is 2. So that's what I'm going to do on the right side. I'm going to multiply the whole side by 2, which means I also have to multiply by 2 on the left side. 2 times a is 2a. When I multiply 2 times 1/2, I get 1h, or just h. And now I still have h being multiplied by this quantity b sub 1 plus b sub 2. Okay, still haven't solved for h yet, but I notice I'm still multiplying. So I have h being multiplied times this quantity. And once again, the way I undo multiplication by a factor is with division by that factor. All right, so the result of this is going to be, since these are being multiplied together, these will just cancel each other. But since I divided the right side by b sub 1 plus b sub 2, since I divided that on the right, I also have to do it on the left. And this is going to give me my final answer. 2a divided by b sub 1 plus b sub 2 is going to be h. Okay, let's try another one. Here, our variable that we're trying to solve for is in the numerator, obviously. And this whole numerator is being divided by 2. Okay, since the entire numerator, I cannot divide 2 into a without also dividing 2 into b and c. So when I divide, I have to divide into this whole numerator. You can think of these three terms that are being added together as a group that cannot be separated with the division. So therefore, I would recommend, to make this a little bit easier, and as a reminder, I would just put parentheses around this numerator. Okay? Because what that's going to do for me is, when I think of PEMDAS, I now have two parts of PEMDAS being represented in this fraction. I obviously have division by 2, but I have now included parentheses. Okay, so think of parentheses as trumping anything that would be involved inside the parentheses. Think of the big picture, and that's going to make this easily solve for B in really 2 steps. So you're going in reverse PEMDAS order, and so in reverse order we would undo division first, and the way we undo division by 2 is multiply by 2. So here I'm showing multiplying by 2 on both sides, and that's going to give me 2s. And on the right side, the result of multiplying by 2, it undoes this dividing by 2. Those you can think of as canceling each other, and the result is going to be the numerator, a plus b plus c. Well, I have the same operation being performed by 2 different numbers, so we can just combine them into one step. The way we undo addition is with subtraction, and we'll do that on both sides. These are all unlike terms on the left side, so I'm just going to show it as 2s minus a minus c. That will be the left side. On the right side, these would cancel. These would cancel, or make 0, leaving us with b, which is what we were asked to solve for. So that ends up being our answer in solve for b form. Okay, when you get to problems 25 through 28 on your homework, you're going to have a little bit of an added instruction. And solving for x is basically what we've been doing previously, but I want to talk at the end. After we solve for x, we'll talk about what it means to find any restrictions on the variables that were given. Okay, well, let's first talk about how to solve for x. There's really 2 operations involved on this left side of the equation. So once again, let's identify the parts of PEMDAS that we see. I see addition and I see division. Okay, but if I'm going to go in reverse PEMDAS order, I'm going to undo addition first, and the way I undo adding 8 is with subtracting 8. And the result of subtracting 8 on both sides of this equation, remember these would just cancel, that gives 0, leaving me with x over a equals b minus 8. Okay, so I undid the addition. Now let's undo dividing by a. And the way we undo, or the inverse of dividing by a, is multiplying by a. Okay, that would cancel these. And we're left with, remember though, this a is being multiplied by the entire side. And I can show that in one of 2 ways. Either is correct. This shows a being multiplied by the whole side. And that would be okay if you left your answer like this. And it would also be okay if you went ahead and did the distributive property. So I will accept either one of these as an acceptable answer. Okay, so we've taken care of solving for x. What does it mean to find restrictions? Well, we had this discussion in class. Years ago you learned, and this is a completely separate analogy, separate from this. You learned years ago that this situation, dividing by 0, is not possible. It's considered to be mathematically undefined. It is impossible to divide by 0. You also learned back probably in pre-algebra that the purpose for variables is that variables represent numbers. Okay, so I just took my fraction here and I changed it into a variable expression in the denominator. So restrictions pertain to variables. Even though variable, in this case the variable x, stands for any number, for example, I could let x be 1 and I would get 6. I could let x be 2 and I would get 3. I could let x be 3 and I would get 2. And we could do this for any number, any real number we want for x, except I couldn't do that for x is 0. Because again, this is not possible. So when we're talking about restrictions, we're saying, are we going to have to limit what x can be in this case in order to prevent this situation of dividing by 0? And the answer is yes. I cannot allow x to be any number it wants to be or any number I want it to be, because there's one number that x can never be in this case. So in this case, we'll go ahead and finish it. We can let x be any number we want except 0. Okay, so jumping back over to our problem, I'm going to look in the original problem and I notice that I'm dividing by a variable. We have the potential of dividing by 0 if we allow a to be 0. I can let a be any other number I want, but I cannot let it be 0. If I do, we have this case that is not allowed. So in addition to solving for x, I'm going to have an additional answer. There is a restriction on a, and it is a cannot be 0. All right, so that is the complete answer for this example number 4. Okay, let's try this one. Same instructions, solve for x. I'll throw up the PEMDAS again for you so you can see the letters. And let's identify the parts of PEMDAS that we have in this problem. We have addition, we have division, and we have multiplication, all involving this side on which x is, the right side. So let's just undo them one at a time. As we come to them, let's undo the addition first. What is the inverse of addition? Well, that is subtraction. So I'm going to show subtract b from both sides. D minus b is equal to 2x over a. Remember, those would just make 0. Okay, takes care of a. Now let's undo division. How do I undo dividing by a? Well, the inverse of dividing by a is multiplying by a. All right, and remember, a is being multiplied by this entire side. So I'm okay if you want to leave it as this without doing the distributive property. That's fine with me. Okay, these would just cancel each other. And then there's only one operation being performed on x that remains, and that's multiplication. And how do you undo multiplying by 2? Well, you could just divide by 2. Or if you want to, you could multiply by half. And so here is our solve for x answer. I'll just bring it down here. Without doing the distributive property, you would show it as, that's a d. A times the quantity d minus b over 2 is equal to x. Or it would be okay if you did distribute and get rid of the parentheses. Okay, so let's talk about restrictions. Do we have variables that need to be restricted? Or in other words, we've got to prevent or limit what the variables can represent. Now let's start with the original problem. do you see a potential for dividing by 0 anywhere in this original problem? Well, I do, because we have the variable a here, and a stands for numbers. But we're going to restrict a so that it can't be one particular number, because if it is 0, then we've got that case of dividing by 0, which is not allowed. So we do have at least one restriction, but you don't only have to look at the original problem, but you also need to look at your final solve for variable, whatever that variable is, in this case x. You need to look at this, your answer. And the only division I see here is dividing by 2, and we're not ever going to have to worry about dividing by 0 here, because 2 can never change. So there are no restrictions on our answer. So this ends up being the final answer. We have solved for x. We did find a restriction. It came from the original problem. And to keep from dividing by 0, we have to limit what a can represent. It cannot be 0. All right, I think I've got one more. Okay, this is like number 28 on your homework. Let's take a look at, we're solving for x. All right, so once again, I'll just keep this before you. Identify what you see. Okay, I see multiplication, so I'm going to put a little check mark. And always, if you see parentheses, go with parentheses. Don't go with operations inside parentheses. Just check off the P in for parentheses in PEMDAS. Okay, think of parentheses as being the bigger picture. It trumps anything, any operation inside the parentheses. So you don't want to check off the individual operations within parentheses, just the parentheses themselves. Okay, so how do we go about reversing, or what is the inverse of multiplying by 3/4? Well, hopefully you're thinking, well, that would be multiplying by the inverse of 3/4, which is 4/3. So my first move is to multiply both sides of this equation by 4/3. It's going to cancel these. Leaves me with x minus 2 on the left side and 4/3 y on the right side. So in reverse PEMDAS order, we did the inverse of multiplication first. That's done. Now, what was in the parentheses, we can take care of that, and that's pretty easy. How do you undo subtracting 2? Well, hopefully you're thinking, well, that would be adding 2. And that's going to get us to our answer pretty easily. We were asked to solve for x, and we did. And now let's see if there are any restrictions. Do we have any variables that need to be limited as to what they can, the number they can represent? Well, that's only going to be a problem. We're only going to have restrictions if we have fractions that contain variables in the denominator. Well, I'm looking at the original problem, and I don't have any fraction that has a variable in the denominator. So there are no restrictions contained here. And in the final answer, I don't have any fractions that have a variable. I have a fraction, but it's got a constant in the denominator. So I don't have any fractions that contain variables in the denominator. So there are no restrictions, and I need for you to tell me that so I'll know that you checked. Okay, so this is a case where our variables are not restricted by any particular number to prevent division by 0. All right, so I've given you some good examples that will help you for the homework, and please see me after school, or I'll be here in the morning. You can see me during academic support before school if you have any questions, but check out the videos first, not only the class lesson, which you're seeing now, but see if there are other videos that provide help on the particular homework problems. And then if you're still struggling, make sure you see me, and I'll do my best to help you out. Let me know if you have any questions.